Welcome to Orchestrate All the Things. I'm George Anatiotis and we'll be connecting the dots together. Stories about technology, data, AI, and media and how they flow into each other, shaping our lives.
In business, they say it takes 10 years to become an overnight success. In technology, they say it takes 10 years to build a file system. ScyllaDB is in the technology business, offering a distributed NoSQL database that is monstrously fast and scalable. It turns out that it also takes 10 years or more to build a successful database. This is something that Felipe Mendes and Guilherme Nogueira know well. Mendes and Nogueira are technical directors at ScyllaDB, working directly on the product as well as consulting clients. Recently, they presented some of the things they have been working on at ScyllaDB's Monster Scale Summit, and they shared their insights in an exclusive fireside chat.
I hope you will enjoy this. If you like my work on Orchestrate All the Things, you can subscribe to my podcast, available on all major platforms, my self-published newsletter, also syndicated on Substack, HackerNoon, Medium, and DZone, or follow Orchestrate All the Things on your social media of choice.
So I'm Guilherme Nogueira. I'm a technical director here at Scylla, and I've been a solutions architect in my career here. So I've got a lot of contact with prospects that are really looking to Scylla to learn more and possibly use that for production. And for that matter, ScyllaDB is a really fast NoSQL database, really aimed towards performance and extreme scale that allows work scale to escalate to multiple millions of operations per second at a really low tail latency.
As for me, I am Felipe Mendes. Just like Guilherme, I also work at ScyllaDB as a technical director. I've been here at the company for about 4 years now. Wow, time flies. But as Guilherme said, we call him Gui, just so you know. I love this database. I think its architecture is really beautiful, and we can definitely discuss more about that. What really makes ScyllaDB unique on its own things like its shard per core architecture, its unique cache. But as for my time here at ScyllaDB, I co-authored a book called Database Performance at Scale. I also contributed code to ScyllaDB. So I try to be pretty much involved in all the things in multiple areas here inside of the company. Nice to meet you, George.
Great. Well, thank you. Thank you both for the introduction. And I guess a little bit of background about myself, contextual background maybe in order. So I just realized just by browsing your recent event, actually, that it's been 10 years that ScyllaDB have been around. And out of those 10 years, I've been in one way or another involved, let's say, or familiar with this database for 8 of those years. So it was 2017 when I first became aware. It was also the time that I happened to meet ScyllaDB's founder and CEO, co-founder actually, Dor Laur. And so I've been kind of keeping track as much as one can keep track, on a kind of yearly, let's say, check, or sometimes I have to admit even less than yearly, but I'm fairly familiar with what Scylla does and also its evolution over the years. And I realized that because apparently of the fact that it's been 10 years since its inception, let's say, at your recent ScyllaDB event, there were a number of talks that were actually dedicated precisely to this topic. So the evolution of the database over the years and the major milestones. And I think, Felipe, one of those talks was actually yours. So you're probably the right person to ask you to give us just a bit of a review, let's say, of Scylla's evolution over the years and what you think were the major milestones along this course.
Of course. I think that's a really great question. And this was, in fact, the keynote that our CEO basically made. He made an analogy during his keynote where he said that, well, it takes 10 years for one to develop a database. Well, it turns out that it also takes 10 years and even more for one to basically build a database. So, as you said during my talk on Monster Scale Summit, I also give a very quick overview over how I actually see the multiple ScyllaDB generations. And when ScyllaDB first started, it was all about raw performance, right? We wanted to be, and we still are, the fastest NoSQL database available in the market. And we did that. One analogy that I like to make without going too deep into the weeds is basically imagine that we were basically a team of operating system engineers, and we basically brought all this knowledge on how to build really low-level, high-performance stuff, but to the realm of databases. And that's how ScyllaDB started. That's how ideas such as the shard per core architecture essentially began. And back at the time, we were basically able to break several records. However, as you can imagine, simply raw speed does not really make it a good database. We need to be compatible. We need to have features, things like materialized views, secondary indexes. We needed to have integrations with other third-party solutions which are widely used in the market. And that's basically when we started going throughout our second generation, where basically ScyllaDB started to actually catch up with the Cassandra protocol. We call it CQL, the Cassandra query language, and we started implementing all the technical depth that we had. A few years after, we eventually landed into our third generation, which basically marked our shift to the cloud. That's when we announced our fully managed ScyllaDB cloud service. And we built several features for customers to integrate their existing ScyllaDB deployments with their upstream systems, things like Apache Kafka, Apache Spark, Elasticsearch. That's when our change data capture was born. Another feature that many people don't know about, and Guy can perhaps talk about a little bit about it more later, is basically ScyllaDB Alternator. So we also basically have a fully compatible DynamoDB API, which is what we call ScyllaDB Alternator today. And the next generation of ScyllaDB was basically when we started breaking apart from some of the deficiencies. That's how I would at least refer to it. Deficiencies existing in the Cassandra architecture, where basically we started introducing Raft, and it's basically marked into our road to eventually get to a strongly consistent system. The next generation was basically it's basically where we currently stand at, which is our road towards elasticity with tablets. So lots of features, lots of very interesting things for us to discuss. I hope I teased some words which unfortunately some of the audience may not know about it, but I try to be very succinct.
Yes, indeed. So thanks, Felipe. And just to pick up on some of the things you said, that again, since through my own involvement, let's say on superficial as it has been with the database, I've been able to identify, let's say, some of the themes over the years. And one of the things that you mentioned, so the ScyllaDB Cloud, has definitely been one of those. And so evolution of ScyllaDB Cloud and the fact that ScyllaDB has been increasingly used as a CAS, and all the migration paths from other data management systems and databases. These were the key themes that we identified in the previous ScyllaDB chat that we had with Dor. And looking at this year Monster Scale Summit, it seems that these are still there, and some of the key themes that have always characterized ScyllaDB are also there. So cost reduction, high availability, scalability, and elasticity. I also noticed with interest that there are a few things that are new, such as the addition of vector capabilities, and some things that I originally thought they were new, like the workload prioritization, but it turns out that maybe they are not so new after all. So I guess I'm going to ask you then next, Guy, if there's any out of those themes that you'd like to pick and just share a few words about.
Sure. So in general, vector capabilities is one thing that we're recently implementing and working on. So this will actually match some of the Cassandra features, but also extend it in a way that will be unique to Scylla in the future. And the way that that happens is currently we have the implemented data types, data structures, and query capabilities of working with vector types. Those are actually basic data types of the database. And as we extend that project, we also cover a service to do indexing and work on indexing for those data points in vector. So vector search will be part of the future of ScyllaDB, especially in Scylla Cloud, where we aim it to be a fully managed service, not only for Scylla, the base core database, but also for this extended layer.
Okay.
And
Yes.
in terms of workload prioritization, you also mentioned that it's seemingly new, but it has actually gaining a lot of traction because customers realize that they can run multiple workloads on the same cluster. So even if they have concurring live, real time, and analytics workloads, they can run both of them in the same cluster, which is not the case with Cassandra. That you can have a target for latency on your online and batch or analytics operations and still hit those marks while saving a lot of infrastructure and licensing cost as you're running you're leveraging the same hardware.
Indeed. And just to give a bit of my own perspective, let's say, on this, the reason why I thought originally that this is a new feature is, well, a couple of reasons. In fact, first, the fact that I wasn't aware of it. So I thought, well, if I didn't know, it seems like a really useful feature. So if I wasn't aware of it, it must be new. Plus the fact that there was a talk on this in the recent event from Felipe. So I thought, well, this looks really cool. I didn't know about it. There's a talk, so it must be new. So Felipe, do you want to clarify? So when exactly was this introduced? And is there a specific reason why you chose to highlight it this year? Is there maybe something new added to the existing capabilities?
So, thanks for your question, George. Workload prioritization was introduced in 2019. There are always new features and capabilities. Not I can't recall of anything specific for this year, but a few years back, probably last year or the year before, we actually introduced a feature called workload characterization, which basically extended the previous workload prioritization capabilities. And the idea of characterizing a workload is that if you stop and think about it, users basically run and use a database in a variety of ways, right? But the main reason why most organizations typically run ScyllaDB is when they need very high throughput and low latency workloads. Yet, I mean, sometimes they may need to run some very intensive batch workloads, some sort of analytics, or they may have a user who is running ad hoc queries, either because they're debugging something or doing any sort of data analysis on his own. And what happens is that it's very challenging for a database alone, to actually know how to prioritize one query versus another, right? And this is really the power that workload prioritization gives to the user. So you basically can assign different service levels. That's the technical term we came to it. And each service level is going to be isolated from another, which means that if you have a service level which has lower priority than your main workload, and your database is currently running under contention, meaning that either its CPU or memory or disk resources are basically overutilized, then ScyllaDB will start prioritizing the workload you defined for it to prioritize. So it's a very interesting feature. It's unique to ScyllaDB. No other database has anything close to that. And I believe the reason why we are calling out this year is because basically, as you said it yourself, you were not aware of it, right? So many users still are not aware of all the unique ScyllaDB features that we have in comparison to other databases, and we every now and then want to call it out again so that we bring more awareness to our users and community.
Okay, cool. That's a great segue for me to ask. Well, there was quite a variety, lots of themes in your lineup for the event you just had, and lots of user presentations as well, which is always good. Do you have? I'm guessing that you must have watched them all, or at your own time, because they're also available on demand. So I'm going to ask you both, starting from Yugi. Do you have a couple of favorite use cases?
So I have one that is really close to my heart, which is Medium's feature store redesign. I work closely with them in the SA or solutions architect capability, and I help them discuss and remodel their data set in order to achieve the results that they presented during the event. So that one, seeing that materialized as a public presentation, even though I was not mentioned, I was still greatly happy to see them on screen and gather so much attention of how much impact and positive impact a good data modeling and reasoning about your access patterns makes for ScyllaDB success. I would also highlight Udmos, which is another prospect that I work a bit close with, which migrated from Dynamo into ScyllaDB Alternator with extreme great success, reducing cost, improving latency, and being able to be flexible on their vendors, or cloud vendors in general.
Okay, thank you. How about you, Felipe?
Wow, that's I could probably speak for an hour just on that. But I mean, before I actually talk about customers who actually spoke at our recent conference, Monstrously Summit, I would like to basically call out back on what Guy said, because he basically mentioned about Medium's feature store, and I worked somehow closely with Clearview AI. They gave a talk about how they are using ScyllaDB as an AI workload. And that's very interesting because I see nowadays we have lots of new AI and machine learning stuff coming up, right? And another particular customer that I had the opportunity to speak along was TripAdvisor. So last year at AWS reInvent, TripAdvisor and I spoke at AWS reInvent, where TripAdvisor basically spoke how they use ScyllaDB to basically service the real-time features. So imagine whenever you hit the TripAdvisor website, they quickly need to figure out who you are, because probably you used TripAdvisor in the past, right? I don't know, maybe you were planning a trip to go, I don't know, to Lisbon, Portugal, and you decided to book something with them. And then as soon as you visit their website, they use ScyllaDB to quickly retrieve this data, identify who you are, and then provide you recommendations in real time on their website. So as you can imagine, this has to be really fast because users' attention spans is not very high, right? So if this takes, I don't know, 300 milliseconds, that are very high chance they may lose the user. So they have a very interesting talk on how really ScyllaDB helps them to provide those real-time recommendations to their users. Now, back to the main question, which is talks specific to our Monstrously Summit. A particular customer talk that I also love was basically Discord's on how they basically, well, they had 2 talks, right? How they basically run trillions of searches at scale. This was how Discord basically manages their Elasticsearch infrastructure. But related to ScyllaDB closely is basically how they run upgrades really at scale. So I also had the opportunity to work really closely with the Discord team. I think they're super smart. I always learn a lot of working with them. So if they are listening to this, somehow, guys, thank you so much for everything you guys taught me throughout all those years. But yeah, it's a very interesting talk, and the way they basically manage their distributed systems is really amazing.
Cool. All right, so I guess it's a good time to head back to one of the features, or rather two of the features you talked about early in the conversation, which I think, based on my understanding, are kind of core to the evolution of ScyllaDB. And they're also very, very new. These, we are certain that they are new. So we're talking about tablets and strong consistency. So tablets is a new data distribution algorithm that in the latest ScyllaDB version is replacing the legacy vnodes approach that was inherited from Cassandra. And there's a strongly consistent topology updates for metadata. And I think before we get to discuss about what they are and the motivation and some use cases, I think it's useful if we start by introducing a bit of background. So first on the Paxos versus Raft protocols, because this is central to understanding tablets, and also a little bit of background knowledge on strong versus eventual consistency, because again, this is kind of fundamental knowledge to be able to follow this. So who wants to pick what?
So with regards to the Paxos and Raft comparison, the initial algorithm that was used and inherited from Cassandra, implemented for strongly consistent operations, data operations, relied on Paxos. And now Scylla is not only applying this to topology updates, but also to metadata updates, meaning that whenever there is any change in metadata or any topology change in the cluster, that change is approved and committed by the Raft distributed consensus algorithm. So in this case, we can do that fairly rapidly, consistently, and really in a distributed scale. So for instance, only on this aspect, and we can talk about tablets later, it allows clusters to be scaled or joined in the nodes to be joined in a cluster in mere seconds rather than the previous distributed algorithm, which was Gossip for cluster topology, which allowed only a single node to join the cluster at a time. So if you had to scale from 3 to 6, that is a linear operation of adding one additional node 3 at a time from buckets of 3. So in that sense, when we change the strong consistency for topology updates and also for metadata, we can also now add 3 nodes instantaneously to the cluster and then allow the cluster to rebalance itself using tablets, which we'll touch later on.
Yeah, and with regards to your second question, which was the difference between eventual consistency and strong consistency, I would like rather to give you an example. So Guy mentioned about the Gossip protocol. And the thing about Gossip, and by the way, Gossip is still used inside Scylla, but we are, as part of this Raft effort, which we are still going on with, we are basically more and more relying less and less in Gossip. So let me give you an example on how things worked before we actually had Raft. So before Raft, if you were to basically bring down a node, suppose you're going to bring down a node for changing a configuration, upgrading it, whatever. You bring down a node, and because Gossip is basically a pandemic protocol, as soon as a node goes down, not all nodes in the cluster are aware of that, of the fact that this node went down immediately. This information takes some time to propagate, right? So imagine you have a cluster, which for ScyllaDB is very easy. I don't know, 100 nodes. So you bring one node down, and then because gossip is a pandemic protocol, one node communicates with another, and then this other node communicates with another, and then this one node communicates with another. So there are lots of round trips going on out here, and it takes time for this information to disseminate throughout the cluster. So it could happen a situation like this. You shut down a node because you were going to do a maintenance operation, but another node took too long to recognize the fact that the node was down. As a result, simply because you shut down a node, boom, your latency spikes, and you never understand why until you realize that it's because it took too long for gossip to actually disseminate that information. With Raft, basically we have a state machine. So Raft, we have a single leader, and whenever those metadata changes and states changes actually happen in the cluster, this information is first sent to that state machine, and then all nodes communicate with that state machine, and they automatically will realize that, okay, one node is down, so we have to flag this node down, and then your application can continue running without taking it too long for a specific node or a group of nodes to actually realize that something changed in your cluster. So that's basically a good way to differentiate the eventually consistent from strongly consistent. In a way or another, both systems will eventually converge to the same state. At the end of the day, no matter how long it takes, all systems will eventually realize that one of the nodes went down. The problem is, or the solution is, how fast can that realization actually came to be.
Okay, so I have a question. You mentioned in the second case, so not the gossip, but using the Raft protocol that it's a state machine, and you have a leader that the rest of the nodes communicate with in order to get informed about the up-to-date status of the cluster. So obviously, I'm going to ask you, right, so what happens if your leader goes down? I guess there must be some kind of, resilience. Yeah.
Yep. So by default, there's an election process. One of the difference between Paxos and Raft is that basically Paxos is a leaderless consensus protocol, right? So there is pretty much no leader. But with Raft, you always have a single replica, which is considered to be a leader. So naturally, you might realize that, okay, isn't this a single point of failure? Yes, it is. But with ScyllaDB, basically, we never have a single leader. For example, with tablets specifically, we have one leader per tablet. And the idea of tablets, and because I know we are eventually going to diverge to discuss more in depth about tablets, is that a tablet is basically a logical abstraction that basically partitions your data, your tables, into smaller fragments. And the name of those fragments, we decided to call them tablets. And those tablets, they are independent from the rest, which means that ScyllaDB with Raft can atomically and in a strongly consistent way move them to other nodes as needed and as your workload grows or shrinks on demand. Yeah. So basically, we have lots of Raft leaders, which means that if one fails, you pretty much don't mind much. An election will happen for those leaders which failed, and you also have many other leaders in other nodes and replicas. Yeah, on a per tablet basis. Yeah.
Cool. So we already started getting into the details about tablets. So you quickly described what they are. Can either of you give a little bit of motivation? So what are some use cases in which tablets are useful?
So I'll get started, Faye. You can add more use cases later. So the way tablets work, by breaking down those token ranges into smaller and more manageable and in strongly consistent way, is that we're able to really quickly move them out along servers. So this is really aimed towards fast scaling of a cluster. So when I say that you can add 3 nodes really quickly into a cluster, that also means that those 3 nodes join the cluster and then rebalance these tablets in a parallel and consistent way, but also extremely fast. So you can scale terabytes of data in mere minutes rather than hours, which was the previous algorithm. And in this case, when we're talking about machines that have higher capacity, that also means that they have a higher storage density to be used. And tablets also balance out in a way that will fill those disks in an even way. So all nodes in the cluster will have a similar utilization because tablets will address the number of tablets within each node according to the number of eCPUs, which is always tied to storage in cloud nodes. So in this sense, as storage utilization is more flexible now, so as we can scale more quickly, it also allows users to run at a much higher storage utilization. Felipe is showcasing here that our aim is to run at, instead of 50 to 60%, up to 90% storage utilization, because tablets and automations in the cloud will also allow us to very rapidly scale the cluster once those storage thresholds are exceeded.
If you stop and think about it, I mean, you must be crazy to run a database close to 90% storage utilization, right? But with Scylla, that's pretty much normal. That's one of the benefits of tablets. So what we are seeing here is exactly as Gil was alluding to. We first start, imagine that this diagonal purple line is basically storage utilization. We start with a small cluster with a single node. This is basically per zone, so it does not really reflect a real 3-node cluster, which would be the minimum we recommend for production purposes. But the idea remains. So imagine that your storage utilization grows over time. And as you reach close to 90% storage utilization, what we do is simply we add a new node. And thanks to tablets, we can really stream that data very, very quickly. In fact, we have some demos showcasing how it works, and we even run very many tests on a daily basis using our ScyllaDB cloud, which guarantee that if you hit 90% storage utilization, tablets will have enough time to actually scale out your infrastructure without letting you run out of disk space. Now, what is the value of this? Why do I want to run my database close to 90% storage utilization? Well, many people say that nowadays storage is actually cheap, right? I mean, compared to memory utilization, they are right. Storage is definitely cheap, but the problem is that it still costs something, right? If you think about those hyperscalers, companies like Apple's and Netflix's, where they basically have thousands of Cassandra nodes. Very likely they are running their storage utilization somewhat close to 50, 70% utilization, which means that they have at least 30% per node disk space that they don't use. Why? Because it's too dangerous, because it takes too long to scale. As Guy also said, I mean, one really benefit of tablets is that you can add several nodes in parallel. So if you want, I don't know, to 10x your traffic, you simply go and you add 10x times the number of instances you have. All Atoms and ScyllaDB will handle all the rest for you. In comparison with other databases, you typically have to run those operations serially. You add one node, then you wait, then you go and add another, and then you wait. And just takes time. So with tablets, you can easily scale out as well as scaling your infrastructure on demand, which means that if you have a workload which is very seasonal, for example, throughout the day, you have, I don't know, to run your peak capacity, but overnight you don't need that spare capacity, you can simply scale your database up and down on demand. And this, at the end of the day, results in even higher costs beyond simply storage utilization. So those are really the main benefits of tablets. But there's a third one that I personally feel is also important. ScyllaDB with tablets bring to users the ability that previously was only available in cloud infrastructure. Think about it. How many databases out there support this kind of elasticity? that you can simply install on your own, deploy on premises, on your own facilities. I can think only of ScyllaDB, other than the ones like Bigtable, Google Cloud Spanner, AWS DynamoDB, and so on. So tablets also allow users to actually have this feature, which was previously only tied to cloud workloads, now to the hands of users.
Okay, so it seems like the main idea here is to get your storage to be more granular, basically, and by doing that, you gain in flexibility. However, usually, nothing comes for free, and there's always a trade-off. So I'm guessing that the trade-off you make in this case is, well, additional complexity in implementation, and I wonder how, if that translates to additional CPU usage, for example, at runtime. Is it something that you have benchmarked?
So in terms of complexity, ScyllaDB and the accompanying ScyllaDB drivers that are compatible with tablets handle everything for the user. So of course that once the user is planning a cluster and a table and some configs for the workload, it has to have some considerations as to, okay, how much data you expect to be in this table, how many breakdowns or how many token ranges should that data be split at creation time. But other than that, that's really non-additional concerns that a user, an end user, might have as they administer the cluster. In terms of CPU utilization, it is even much more efficient in the way that we're doing this now, because as we discussed, we can transfer a tablet from one node to the other as we're scaling. Not only we can do that in terms of tablets, but also the previous way was streaming data. So rows were actually being read and streamed, each one in buckets over the network. And that was not as efficient as it could be. And now tablets will also transfer a single file through the network as it's scaling. So now there's no row per row breakdown of the operations, just a single, very bulk transfer that reaches the maximum network capacity as it's scaling. So that's why it's extremely fast to scale a cluster under these circumstances. Felipe, do you have anything else to add?
Yeah, the feature you just mentioned is our zero-copy streaming, right? File, which you called file-based tablet streaming. Yeah, but you do have a good point, George, because once it turned out, tablet was a major effort, and it still is in a sense. So, for example, there are some features that today we do not support with tablets, but we are working really, really hard to actually bring supports to those features. All those are basically available in our documentation. But in general, the feature is stable, the performance is great, and the benefits are many. So we have run some performance tests. We haven't seen any performance degradation of any sort. But again, it's in a way or another, it's still a new feature. So if there is any performance problem, you know how we basically handle those things here at ScyllaDB. Then it's a bug, and we gotta fix it.
Yeah, just to clarify, I wasn't thinking of complexity for the end user, let's say, but more of in terms of complexity in implementing the feature. So for you guys, the engineers in the crew, basically. And just out of curiosity, how hard was that to implement?
It definitely took some years to get it ready. Basically, tablets involved re-engineering critical paths of our database, and many of those critical paths. For example, compactions, which is a very fundamental background process which exists both in Cassandra and ScyllaDB. We needed to introduce a concept known as compaction groups to basically deal with those tablets and ensure that we do not compact SS tables which are from a different tablet incorrectly. Repair also needed to come with its own changes. As Guilherme said, our drivers all needed to support what we call today as tablet awareness. So as you can imagine, when a client application is going to communicate with the database, the most efficient request is when it hits a node that's also a replica for the data that he's after. So basically, tablet awareness ensures that the driver always know which tablet, which replica, which node is a replica for the tablet that he's querying against. So those were all things that we needed to implement from ground zero, and yeah. So it wasn't easy, but we finally got to a state where we can finally say, hey, tablets is production ready, folks.
Great. So I guess that means that it's already used in production by end users.
Correct. Mm-hmm.
Okay. And is it also, by the way, it's a good, it just made me think, so what kind of feature parity do you have comparing the on-premise version to ScyllaDB Cloud? And the why I came up with this question is because I just thought, well, all right, so is it also deployed on the ScyllaDB Cloud?
So the way that ScyllaDB Cloud is designed is to actually leverage the very same binary down to the actual binary that you would run if you were running Scylla Enterprise, where you manage it yourself. The only limitations of ScyllaDB on the cloud is that there's few customizations in terms of the integration with the rest of one's infrastructure, such as, for instance, the database deployment is isolated in a single VPC, so there's no outward connection from the ScyllaDB deployment out into the customer VPCs or the customer networks. And then LDAP or any sort of network authentication doesn't make a lot of sense in that scenario. So that's one of the features that are not available on the cloud. Recently, we also introduced data encryption, so encryption at rest, as we call it. And we can also leverage KMS, which is a customer-provided key management system that will manage the keys for the encrypted SS tables, and that can be deployed on Scylla Cloud and could also be deployed on Scylla Enterprise. So as time goes by, we are usually aiming towards covering and minimizing the gap so our users have a much higher value of looking into migrating to cloud rather than managing Scylla by themselves, which can be a pretty complex task.
Yeah, indeed. So last time we caught up with Dor, actually in the two of the previous times that we caught up, so the last one and the one right before it, ScyllaDB Cloud was a major conversation point because each of those times Dor kept reporting year-on-year growth on the ScyllaDB usage and also on the ScyllaDB Cloud usage and also on the revenue. So I'm wondering if you are aware of whether that growth has been going on, basically.
I don't have access to exact financial numbers, but definitely
I wasn't so much talking about that, but more about usage.
No, definitely we are growing. I mean, we see the adoption of ScyllaDB growing on a daily basis. It's actually really, really impressive. And as you can imagine, that's also one of the reasons why we spoke during our summit about many new features we are bringing. Because during our summit, as we already spoke, we spoke about how we are going to implement vector search, but beyond that, we also implemented about our tiered storage with support for S3 object storage, not just S3, right? But when we refer to S3, we basically refer to any object storage for any cloud. And those are the things which really will allow ScyllaDB, once those features are in, to also attract even more users than what we are seeing today. So I would say that, Guy, correct me if I'm wrong, I think on a weekly basis, I at least see a new ScyllaDB user coming in using our cloud. And I mean, the growth has been impressive, and the acceptance of our database is really, 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 really good. I mean, we have lots of very good logos showcased in our website. We spoke about a few already, like TripAdvisor, Discord. We have Hulu, right? Which others am I missing? You spoke about Udemy and their awesome cost
Medium
reduction,
digital
medium,
turbine.
yeah, and so on.
I think I also recall seeing American Express as a user, and a couple of, well, more than a couple other big names as well. But just realized we're very close to wrapping up, and you just mentioned the magic word, so new features. And we've already kind of talked a little bit about Vector, and this is something that honestly I was expecting to see, because I don't think there's like a single database today which is not adding vector capabilities, and well, for very obvious reasons. You also mentioned tiered storage, and again, that's something that in one way or another, I think has been ongoing for a while. I remember Dor mentioning an effort towards utilizing S3 for storage, which I guess is still ongoing. So if you want to talk about those or any other upcoming new features, feel free.
So with regards to tiered storage specifically, it somehow ties back to what I previously said, that users use their databases in a variety of ways, right? When ScyllaDB was originally conceived, again, it was all about raw performance. We want to give you the lowest latency possible. But sometimes users, they don't want to, string their data to another database. Sometimes their data grow too large, and costs become a problem because they have to scale out of their infrastructure in order to accommodate the storage growth. And many times users have data that they read very infrequently, right? So the idea of tier storage is actually to give those users a choice while still using ScyllaDB. Of course, the performance is not going to be the same. We cannot do miracles. I mean, the speed, the latency of accessing object storage is much higher than accessing a local NVMe. But with supporting things like object storage, there are many interesting things we could do. Besides only tiering your storage by itself, we could come up with use cases where, for example, your local NVMEs would only be used as a fast cache, and all your data could be stored only on object storage. I believe Dora already gave this example a few times back. When a node fails, for example, instead of you having to stream data from the existing replicas, you could simply come and retrieve data directly from object storage and continuing servicing traffic from there. So S3, well, object storage in a way, will allow ScyllaDB to make many more things than it's currently able to do today. Yeah.
Okay. Guy, any new feature that you'd like to pick on? I would personally be very willing to hear more about the vector indexing and vector storage. Well, particularly because of the fact that some of the early benchmarks that I saw mentioned seemed very promising.
Yeah, so I think the vector approach really leverages Scylla's speed and throughput and low latency combined with a very well-designed processing and vector search layer. So our teams is still developing the layer. Those were very early numbers from benchmarks, but still I think that's a great sign that how Scylla can integrate really well with those really complex scenarios which require extreme scalability, because you can easily scale to millions of operations per second just to fulfill a couple 100,000 vector inquiries. And you can also leverage Scylla's really extreme low latency and predictable latency in order to fulfill those in a really timely scenario. So for our aim is that for applications that really need low latency and high throughput for those scenarios, they can also continue to leverage Scylla as a product on the back end. I would also highlight strongly consistent user data. We talked about cluster topology changes and actual metadata changes being strongly consistent on the reft, but we're also working towards implementing that on the user layer. So this is extremely initial, so there's no even a POC to demonstrate, but that is an end goal that we have to really leverage the power of Raft as a distributed consensus algorithm to make sure that users have the best capabilities in terms of designing the applications on a strongly consistent manner while running Scylla.
All right. So I think we talked about a number of things actually, and time flew by really, really fast. And we can probably wrap up here unless there's any other, whatever, new feature or any use case or anything you feel that we've left out, and now's the time to mention it.
Well, I just would like to say to our audience that if you're currently struggling with your database, if your performance is not really well acceptable, you might want to check out ScyllaDB.
Agreed.
Okay, cool. That's a good message to close the conversation with. So thank you both gentlemen for joining me. It's been a pleasure.
Thanks for sticking around. For more stories like this, check the link in bio and follow Link Data Orchestration.